through these problems kind of quickly, all right, mostly for you to check your work, and if you see any issues, then you can come and chat with me, all right? All right, so for this problem, you start with 0.3 moles of your Na3PO4. If you notice, you don't really care about what type of compound it is, because all you have to do is the following. Get rid of your moles, so 1 mole on bottom, and then you're going to put molecules up top, so it's going to be your 6.02 times 10 to the 23rd, molecules up top. Okay, pretty simple one. So then what you need to do, grab out your calculator, and you're going to do 0.3 times 6.02 times 10 to the 23rd. What you should get is 1.8 times 10 to the 23rd. Here's the important part. You need to write your units. So your units are going to be molecules, and then you're done. Okay. Next one, you're given one molecule, so that's how you start. Okay. You should never be looking at your periodic table to find your given, guys. It should be right there in front of you. So that one molecule, crisscross swoosh. Okay. I'm going to put 1 mole up top. I'm going to put molecules on bottom. So the 6.02 times 10 to the 23rd. Molecules. Okay. Not too bad. Now I'm in moles, but I want to be in grams, so I'm going to crisscross swoosh again. I'm going to put 1 mole on bottom. All right, grams up top. Now I need to calculate my molecular mass of this compound, and when you do that, adding PB, S, and 4 O's, you should get 303. Okay, so now what you're going to have to do in your calculator, 1 divided by, in parentheses, 6.02 times 10 raised to the 23rd, and yes, it has to be in parentheses whenever you divide. Then you're going to multiply that by 303. And you should get 5 times 10 to the negative 22nd, which makes sense because one molecule should have a tiny mass. And remember, you need grams for your units. Okay? Next one, you have 34.2 liters, and you want to convert that to grams. So I'm going to crisscross swoosh. I first want to go to moles. So I'm going to put 1 mole up top. Remember, you can't go from liters to grams directly. I'm going to put 22.4 liters on the bottom. Now I'm in moles, but I want to go to grams. So I'm going to crisscross swoosh again. I'm going to put 1 mole on bottom. And I'm going to put the molecular mass of CH4 on top, which happens to be 16 after I calculated it. Okay, so now you're going to take 34.2, divide that by 22.4, and multiply that by 16. And what you end up with is 24.4 grams. Okay. Remember, units are important. Now, this next one for calculating the percent composition, you need to first find the molecular mass of this entire compound. So calcium has an atomic mass of 40, so this is going to be 40 times 3, which is 120. Okay, plus, if you look up phosphorus, the atomic mass of phosphorus is 31, so it's going to be 31 times 2, which is 62. If you can't do this in your head, guys, that's fine. Put it down on paper. Then oxygen, how many oxygens do you have? Well, you actually have 8, right? Because 4 times 2 is 8, so it's going to be 8 times 16, because that's the atomic mass of oxygen, so it's going to be 128. So the total, when you add all of this up, 120 plus 128 plus 62 gives you 310. Now, to find the percent composition when I'm only given the compounds and not the grams, you need to take the atomic mass of each element, which I've written out right here, and divide it by the total. Okay, that tells you how much each element contributes to the total. So it's going to be 120 out of 310. So you're going to take 120 in your calculator and divide it by 310. And what I get is 38.7%. So I'm going to put 38.7%. Perfect. Next one, 62 divided by 310. And I get 20%. Okay. The next one I do, 128 divided by 310, and I get 41%, 41.3%. Now, if I take all of these up and I add them all together, 38.7 plus 20% plus 41.3, what you'll find is you get 100%. If you get 99%, that's fine. If you get 90%, you've done something wrong. All right? Now let's do this next one. It says, what is the empirical formula for a compound that has this amount of iron and that amount of sulfur and that amount of oxygen? So what I need to do, since I'm given grams, I need to convert that to moles. So I'm given 0.0134 grams of iron. Okay, so I need to convert that to moles. I need to convert 0.00769 grams of sulfur to moles as well. And then over here I need to convert 0.0115 grams of oxygen to moles. Okay, so I'm going to crisscross swoosh. 1 mole up top. This is nothing new, hopefully. And I have 55.85. That's my atomic mass of iron. Okay, when I divide, when I take 0.0134 divided by 55.85, what I get is 0.0002. If you guys got in your calculators 2 times 10 to the negative 4th, that's perfectly fine as well. Alright, so what I end up getting is 0.123024. That's fine. Okay, 2.4 times 10 to the negative 4th is the exact same thing, guys. Don't freak out about it. Okay, I'm going to put 1 mole on top. And the atomic mass of sulfur is 32 grams. Okay, now I'm going to crisscross swoosh, so I'm going to divide. 769 divided by 32. And I get the same thing. I get 0.00024. Okay, same thing here. Crisscross swoosh, 1 mole. Notice I'm not skimping on the amount of detail I give, even though I've done this like 100 times. 0.0115 divided by 16. And I get 0.00072. Okay, so I need to now divide by my smallest number of moles, which as you can see is going to be 0.0024. And when I divide 0.0072 by 0.00024, I get 3. That's going to be 3. So what my final answer is going to be is just FeSO3, and I'm done. Okay? For number 6, what you guys need to do is determine your number of grams of each of these. And so what you'll find out once you do it, you get 145.946. This is given to you. This is nothing new. 46 grams of carbon. Okay? You get 24.3243 grams of hydrogen. Okay? And then the only tricky thing here, since you have a total of 300, I don't tell you how much oxygen is given. You have to subtract the 145 and the 24 from that original 300 to find out how much of it was oxygen. And what you should get is that the mass of oxygen is 129, let's round, 0.7 grams of oxygen. So your steps are going to include, I'm not going to do them for you, you need to crisscross swoosh for each of these, find your number of moles. Once you found your number of moles, okay, then you are going to, once you find your number of moles, then you divide by your smallest number of moles. So when I do this, what I get for my smallest number of moles, well, I'll write what I get for my number of moles of each. This is going to be 12.16. This is going to be the same, the 24, because I divided by 1. Okay, and then the oxygen is going to be 8.1. So I need to divide by my smallest number, which is my 8.1. And what I end up getting is, for my carbon, I get 1.5. Okay, something should seem wrong right now. H, since I'm doing 24.3 divided by 8.1, I get 3 here, and I get 0.1. Now, no, you cannot round that 1.5 to 2. That doesn't work. But what I can do is make that a 3 by multiplying that by 2. If I multiply this by 2, guys, I have to multiply the entire thing by 2. So this becomes C3H6O2. And I'm done. Okay? Number 7, really quickly, a sample with a molar. So I tell you that it has a molar mass of 34. Okay, I give you the number of grams of H, the number of grams of oxygen. Same thing here. Your first step, you have to find the empirical formula, just like we did in 6 and just like what we did in 5. All right, what you'll find, this is very simple. Once you get you take your grams, you convert it to moles. What you'll get for your empirical formula is HO. The only new step you need to do now to find your molecular formula, you need to take the molar mass, which is 34, that's given to you, and divide it by the mass of this. Now, hydrogen is 1, oxygen is 16, so the mass of that is 17. All right, so HO, when you divide this, that's going to be 2. That's your multiplier. So you need to multiply this entire thing by 2, so it's going to be H2O2, and you're done. Okay, so it's just one new step in addition to that finding the empirical formula. All right. Now, for this one, same thing as before. What you'll end up with after dividing your smallest number of moles, you'll end up with NO 2.5. Okay, once you went from grams to moles, divided by your smallest number of moles, you'll get NO 2.5. If you can't get that, come in to me and I can help you. Okay, so once you get that, since that's 2.5, what you should realize is that you can't keep it like that. So instead you need to multiply the whole thing by 2, so you end up with N2O5. That's still your empirical formula though, right? You can't reduce that, so therefore it's still your empirical formula. Now, I want to find my molecular formula. So I take that 108, which is given to me, and I need to divide it by the mass of this. Okay, what you'll find actually is that the mass of that is 108. So what that's telling us is that this is not only our empirical formula, but it's also our molecular formula. All right? Okay, for our last problem, what we're going to do is we have to write the formula for a hydrate. So I give you that you have 5 grams of your hydrate, so you have 5 grams of it, and you're going to heat it up until it's 4.26 grams. So what that's telling you is that 4.26 grams is going to be just pure BaCl2. Right? Because the rest of it, the rest of what was let out, which happens to be 0.74 grams, which I'm going to write up here, was just pure water because that evaporated. Okay, so it's going to be the exact same steps as before. I need to convert this to moles, so crisscross swoosh. Okay, 1 mole on bottom. You're going to put your molecular mass, 1 mole on top, molecular mass on bottom, so 208 on the bottom grams. Okay, same thing here, crisscross swoosh, 1 mole, 18 grams on bottom now. And so what I end up getting when I take 4.26 and divide that by 208, I get 0.02. So the way that I would write this formula, this is the only additional way that writing your formula of a hydrate changes. You would write 0.02 because that's your number of moles of BaCl2, so you put 0.02 BaCl2. This is basically the same problem as what we did before in class, but BaCl2. Okay, and then I'm going to put a dot because that represents the water being bound to BaCl2. When I divide these guys, I get 0.04 H2O. I'm like crazy running out of space. Okay, so when I divide, what I end up getting, I'm going to divide both of these by 0.02. I end up getting BaCl2 dot 2H2O. Okay, and I'm done. That's my formula for a hydrate.